Good morning. Welcome back to Open Med School. In the last two sessions, we have discussed about upper motor neuron and lower motor neuron lesions and the clinical features. In this session, we will be discussing about how an action is planned and implemented and what are the tracts which are concerned with these things. So, consider you want to take an object like this or a cup of coffee. You develop an idea either through the visual or you could develop a idea for taking a cup of coffee and object. So the impulses are generated or the idea is generated in the frontal lobe, and from the frontal lobe impulses travel down to the spinal cord to the lower motor neuron, and this pathway is the upper motor neuron. The lower motor neuron gives the appropriate impulses so that the muscle contraction occurs and you are able to hold the object. Once I hold the object, what happens? I get sensation, and the sensations are passing up to the cerebral cortex, and the cortex gets information that you have held the object. And the necessary force of contraction and coordination of movements are by the basal ganglia and cerebellum. Cerebellum mainly coordinates, and the basal ganglia gives appropriate inputs so that the actual or correct power is exerted. So this is how an action occurs. So we'll make it a little more simplified. That is, cerebral cortex gives the information. It passes down via the corticospinal pathways. At the same time, the cortex gives information to the basal ganglia even before the pathway comes down. So from the basal ganglia, impulses reach the thalamus. From the thalamus, it goes to the cerebral cortex. Again, the cerebral cortex gives information via pons to the cerebellum, and cerebellum gives information back via thalamus to cerebral cortex. So there are different circuits like this which controls the and coordinates the movement. Hope this thing is clear to you. Now you look at how the cortex controls. First, we look into the organization of the cerebral cortex. So here you can see the coronal section. You can see the leg is represented in the medial aspect, and the face and the upper limbs are on the lateral aspect. This has got clinical relevance because if there is a problem in this area, you will have disordered upper motor neuron function in the leg area. If it is in this area, you will get a upper motor findings in the face area. So that is the relevance of knowing this somatotopic organization. So here you can see the primary motor cortex. So all of you draw a picture like this. So here comes the central sulcus. Just anterior to the central sulcus is here is the motor cortex. And anterior to the motor cortex, you have got a premotor area, and above that you have got a supplementary motor area. In addition, there are speech area, that is the Broca's area, and the frontal eye field. Also, the different motor areas are in the frontal lobe. Remember, the posterior to the central sulcus is the sensory cortex. So this is the sensory cortex, and 40% of the motor pathways are arising from the parietal lobe. This is an important point to be kept in mind. So what are the major motor areas? One is the primary motor, the premotor cortex, supplementary motor area, and the parietal or somatosensory cortex. Okay. So if you want to know the areas by Brodmann's number, the primary motor area is area 4, and the premotor is area 6. Supplementary motor area is area 6, and the parietal lobe is 3, 1, 2. So these are the major areas, and Broca's area, that is the speech center, is area 44, and frontal eye field is area 8. So frontal eye field is 8, Broca's area is 44, parietal lobe is 312, and primary motor cortex is area 4. The supplementary and premotor areas are area 6. Okay. And this is the homunculus we have discussed. The leg is in the medial aspect and the hands face on the lateral aspect. This should be kept in mind when you discuss about the upper motor neuron lesion producing weakness. One of the most important pathway controlling the movement is corticospinal tract. So let us look a little more details. The motor cortex, 60% arises from the motor cortex and the 40% from the sensory cortex, which we have discussed. Then primary motor area is area 4 and most of the cells are arising from the bed cell, that is the pyramidal cells. And the premotor area is area 6, supplementary motor area is area 6. Primary somatosensory cortex 3, 1, 2 and areas 5, 7 from the parietal lobe also contributes to motor. So this you should remember from where the corticospinal pathway arises. So this is the corticospinal pathway. As the name itself denotes, it arises from the cortex, it passes through the corona radiata, then the internal capsule, it comes down, it passes through the brainstem, that is the midbrain, the pons, and finally reaches the medulla. In the medulla, it crosses over to the opposite side, and that part is called the medullary pyramids. And you should remember that there are motor cranial nerves. The motor cranial nerves are equivalent to the spinal anterior horn cell neurons. So this corticospinal pathway gives impulses to the cranial nerve nuclei. So here you can see there is in the midbrain, the cranial nerve nuclei, there is the external ocular muscles 3, 4, 6, and again in the pons it can give motor supply to the 5th nerve, the 7th nerve, and in the medulla 9, 10, 11 and 12. So all the cranial nerves also get motor supply from the cortex and they are called the cortico-bulbar, not corticospinal. Corticospinal means it goes to the spinal cord. They are called the cortico-bulbar pathway. Sometimes it is called cortico-nuclear. So you now understand the difference between corticospinal and cortico-bulbar pathways. This is a little more clear picture. Again, you can see the fibers are descending down, passing through the internal capsule. All the fibers are close together. Then it comes through the midbrain. So this is the midbrain. And here comes the pons, and in the medulla it is crossing. So majority of the corticospinal tract is crossing, and they are called the majority is crossing. They are the lateral corticospinal tract and influence the anterior horn cell or the lower motor neuron. And a small percentage, around 10%, descends down. Without crossing, they are called the anterior corticospinal tract and they are mainly concerned with the axial muscles. We'll discuss it in detail. So, as we already mentioned, they are called medullary pyramids. There are pyramids are there. It is because of it passing through the pyramids, it is called the pyramidal tract, not because it is arising from the pyramidal cells. And so this is the olivary nuclei. Here you can see the corticospinal, the pyramid is formed in the brainstem, the medulla, and the fibers are crossing over to the opposite side. A small percentage passes, around 10% passes down without crossing, which is the medial or anterior corticospinal tract. So we can divide the tracts into pyramidal tract and extrapyramidal tract. Pyramidal tract means the fibers are passing through the medullary pyramids. All fibers that is descending down from the brainstem or from the upper motor neurons which are coming from brainstem or other centers and not passing through the pyramids are called extrapyramidal. The typical ones are the reticulospinal pathway, vestibulospinal pathway, and tectospinal pathway. These are all examples of extrapyramidal. Why they are called extrapyramidal? Because they are not passing through the pyramids. So now these pathways which are coming down, upper motor neurons which are influencing the lower motor neuron are descending down, and they are called the descending tracts. Or the upper motor neuron pathways are descending. Okay. and you divide one. It is divided into pyramidal pathway or a pyramidal tract and extrapyramidal, which we have already mentioned. And another, you can classify it into crossed tracts and uncrossed tract. And anatomically and physiologically, sometimes you call a medially situated tracts and a lateral. That is in the spinal cord. If you draw the picture of the spinal cord, so this is the spinal cord. Depending upon the position of the tracts, you can call whether they are laterally situated. So this is lateral, and whether they are situated in the anterior part. So for anterior or the medial part. So medial pathway tracts and the lateral tracts. These are the ways in which you classify. How to classify? Pyramidal, extrapyramidal, crossed, uncrossed, medial pathways and lateral pathways. In the next session, we will be discussing about the extrapyramidal pathways and also divide the descending tracts into crossed tracts, uncrossed tracts, medially situated tracts and laterally situated tracts. Hope you have enjoyed this video, and if you like this, share and like the channel. Thank you. Bye.